We're going to look at measures of central tendency, and the three we're going to focus on are mean, median, and mode. And the point is, if we had tables and tables of data, just a bunch of raw numbers, it's hard to get any meaning out of them. So we like to get some summary values that help us interpret the data. And one way of doing that is to look at what is in the center or the middle of the data. Try to get one number that represents all the data and gives you a picture of the center of that data. So what the mean does is it's the same thing as an average. You add up all the data values and then divide by how many there are. So you could add all these numbers up and divide by 10. There's a shortcut in Excel. If you type equals average and then open the parentheses, select your data, it's going to find the average for you. So the next thing we're looking at is median, and just like the median of a road is the part in the middle of the road, we're looking for the data value that's in the middle of our data set. So half the values are above it and half are below it. So to find that, if you're doing it manually, first you have to sort your data. So list it smallest to largest. In Excel, you can go to data sort and then choose smallest to largest, and it'll sort the data for you. And if there's an odd number of data values, you just find the one exactly in the middle. If there's an even number of data values like we have here, there's going to be two that are in the middle. So these two are the ones in the middle. There's four below them and four above them. You would take the average of those two, add them up, and divide by 2. Or Excel can do it all with the function equals median. Select your data, close your parentheses, and Excel, in this case, averaged those two values, which are in the middle. Now, the mean tends to be our first choice for measures of central tendency because it takes every data value into account, adds them all up, and divides it by how many there are. So every data value is involved. The drawback to the mean is if you have an outlier or some number really far away from the rest of the data, it's going to skew the mean towards that number. So if you have a really big number, like let me just add something here, 900. It's going to skew the mean upwards towards 900. If this was a really small number compared to the rest of the data, it would skew it downwards. And so here now I've recalculated the mean and the median, this time including that outlier. And notice how far the mean has been skewed upward. It's actually bigger than all the other data values now because the outlier pulled it upwards. And the median didn't change by much. It's still a very good measure of the center. It's right in the middle of the data. So we prefer the mean because it includes all the data values. But if there are a lot of outliers, the median will be better because it won't be affected by the outliers like the mean is. And the last thing is mode, the value that happens the most. And so you can just look and see that 240 happened twice in our data set. No other value happened 2 times, so 240 is our mode. If you type equals mode.mult and then select your data, Excel gives that back to you. Now, if another data value would have happened twice, if 145 would have been listed twice, we would have 2 modes. 145 and 240 would both be the mode. If no data value happens twice, there's no modes. Now, sometimes the mode can be a good measure of the center. If the value that happens the most is right in the middle of the data, then the mode is a good measure of the center. But it's not nearly as reliable as the mean and median. And you see in this case, the mode just happened to be a number on the high end, so it was a very bad measure of the center. So the mode isn't used as much with quantitative data with numbers, but if you have qualitative data, things like colors or ethnicity or something that has no numbers with it, you can't use mean and median. So the mode then is our only option with qualitative data. It's our only choice for the measure of the center. Sometimes we'll want to find weighted means because some numbers are more important than others. A great example is your grade in your classes. Some assignments, like the final exam, count more than other assignments. So a weighted mean would be how you calculate your class grade. What you do is you take each data value represented here by x and multiply it by its weight, and then just add all those up, and we're going to divide by the sum of the weights, which is typically 1, but sometimes it is a different value. And so here's an example with scores from a class. Here are the scores. Here's the percent that they're worth. So the final exam's worth the most at 30%. Write those as a decimal. 20% is 0.20 and so on. And then we want to take each score and then multiply that by its percent as a decimal. So that's how we start getting the weighted average, and then we just add those up. Add up all the different weights from the different categories here. And then you're supposed to divide by the sum of the weights, and we can just verify that our percentages all add up to 100% or 1. So when we divide by the sum of the weights, we remain with that same answer. This person's grade would be an 89.25 if they had these scores in the class. One more area where we find means sometimes, and it's a little different, is when we have a frequency distribution. So the challenge here is we don't have actual data values. We just know how many people fall into each class. So for example, there's 4 people who were in the height range of 60 to 62, but we don't know if they were all exactly 60, if there was a couple 60s, a 61 and a 62. We have no idea their actual heights. So to do the mean here, we find the midpoints of each class. So remember, add the lower class bound and upper class bound and divide it by 2 to get the midpoint. And then you want to take that midpoint and multiply it by how many people or how many data values you have in that class. Multiply it by the frequency. Midpoint times the frequency. And if I drag that down, I get that for each of the classes. Now we're doing an average, so I want to sum up my values and then divide by how many there are. So what are we dividing by? We're dividing by 19 because that's how many total data values I have. If I add up these frequencies, there's 19. So I'm going to get my value here divided by 19, and that is my average from this frequency distribution. So in addition to having a measure for the center of the data, we want to have a measure for how spread out the data is. And that's what measures of variation give us, is different ways of trying to see how spread out the data is. Is it all clustered really tight and close together, or is it spread really thin? The range is the most basic. You just take the biggest data value and subtract the smallest data value and see what that range is between. So in Excel, there are functions you can use for the range. There's a function called max that'll give you the biggest value from your data set, and you can subtract, well, let's just look at that, it's 240, and you can verify that, and then you can find what the minimum one is by equals min, and then selecting your data, and 115 is the smallest. Sometimes you can just eyeball it, but here we just have 10 numbers. If you had 10,000 numbers, you definitely want to rely on those functions. So if we subtract those, then that is our range. It's 125 from the biggest to the smallest data value. Range doesn't really tell us that much, so we don't rely on it too heavily. We look more at variance and standard deviation a lot more often. And what deviation means is how far the data value is away from the mean. So for any value x, any data value, you take that value and subtract away the mean, and that's that value's deviation, how far away it is from the mean. To calculate the variance, we rely on using that deviation. We're basically going to average the deviation of all the data values. So that's a good way of thinking about what the process is here. So you look at each value, subtract it from the mean, and we're going to actually square that then, add them all up. So this just starts sounding like an average. Add them all up and divide by how many there are. And for the standard deviation, it's the same process, but then we take the square root of our answer. So how are they related? The standard deviation is the square root of the variance. So let me go ahead and show that process worked out. We want to take each data value and find its deviation first. So we're going to subtract it from the mean, which we have our average up here. And the data values that are below the mean are going to come back with a negative deviation. Those that are above the mean have a positive. And if we just tried to average these values, these always add up to 0. The negatives and positives cancel out and it's always going to be 0. So we couldn't really average them. But if we square them first, whenever you square something, it always is positive. So now we can average these numbers because they're all positive. So let's go ahead and sum these up. And then we're going to divide by how many there are. So there was 10. And the standard deviation is just the square root of our variance. So we're going to just take our square root of our variance. And that is our standard deviation. So the standard deviation is really the value that is most representative of that average of those deviations, because by square rooting, we're kind of undoing what we did here when we squared everything. So we're back to our original units. And this standard deviation is the one we use most often in this course. And think of it as an average of all the deviations. It gives a great measure of how spread out the data is. Now, I encourage you to use Excel here. If you just come here and type, so for variance, var for variance dot p, because we're doing population variance, select all your data, it gives you the variance back. And for standard deviation, you do standard deviation dot p again for population, select your data, and it gives you your standard deviation. So again, those formulas they look the same if you're looking at sample data, the same formula in Excel, but this time is var.s and standard deviation.s. So pay close attention if you have sample data, or if you actually have data from the entire population. If you have sample data, use .s. If you have population data, use .p. You'll get a slightly different answer. The difference between the formulas, they're calculated exactly the same, but for samples, instead of dividing by n, we actually divide by n minus 1. So 1 less than the number of data pieces we have. And here it shows that in the book, same formula, but for samples, we're just dividing by 1 less than our number of data pieces. And the reason for that, we're not going to go really far into that. Just know that it gives a much better and more accurate representation of the spread for a sample if you divide by n minus 1 compared to if you divide by n.